CPM Math 3, problem 1-92. We have two functions here we are going to be asked to graph. And function A right here is not in true function form, so I am going to add 2x to both sides in order to get it into like the y equals mx plus b form. So it becomes y equals 2x plus 3. This is a line. You should be able to tell that that is y equals mx plus b form and that it will graph a line. So let's get that on the graph. And here we have the graph of the line y equals 2x plus 3. Notice we have a y-intercept at 0, 3 and a slope of positive 2. So up 2, right 1, up 2, right 1, up 2, right 1, and so on and so forth. So there's our line. Now we need to come on over and graph b, which we do have an x squared here. That means it's a quadratic function and it will be a parabola. And I'm going to get it into y equals form. So again, I'm going to just add this 3 to both sides, so we get y equals x squared plus 3. And so what I'm going to go ahead and do is get this parabola on the graph. All right, so one of the things before I start graphing this I do want to discuss is that we know the y-intercept, the c value here is 3. So we already have a point that's actually going to be on the graph. Oh, look at that. It overlaps our y-intercept of our linear graph. And we also know because the a value is 1, right here, that we have a normal growth rate. And the normal growth rate, we do know it opens up because the a value is also positive. So I can start at my my vertex, which happens to be the 0, 3 here, and I can do a normal growth rate. So that's over 1, up 1, over 1, up 3, over 1, up 5, and so on. So I can do that on the symmetry on the other side as well. Over 1, up 1, over 1, up 1, 2, 3, over 1, up 5, and over 1, up 7, and so on and so forth. So our parabola is going to look something like that. So let's answer the questions that we have. For part C, it is asking us to state the x and y intercepts for each function. So for function A, the x-intercept is over here-ish, and we're going to have to work a little harder in order to calculate that. We know the y value is 0, so let's actually take our function and input or substitute 0 for y equals 2x plus 3, and then we're going to actually solve for x, and that'll give us the x-intercept equals 2x, divide by 2 on both sides, and you get x equals negative 3 halves, which we see that about negative 1.5. My line is a little crookedy, so it's not quite perfect, but it does make sense. Okay, so on the flip side, we want the y-intercept of function b, the parabola here, or excuse me, the x-intercept. Let's talk that first. And notice how it does not cross the x-axis at all, so there is no x-intercept for function b. Okay, now as far as the y-intercept, we can visually see that both of these functions cross at 0, 3. So the y-intercept is at 0, 3, and that is actually quite obvious right here. And the y-intercept for function b, when we rewrote it, is right here. It's always the b value in a linear equation and the c value in a quadratic equation. So the y-intercept here is also 0, 3. Okay, next up, they're actually asking us where do the two graphs intersect. I am not going to algebraically solve this here because it is a pretty easy visual. We have the intersections at 0, 3, and, not ant, 1, 2, 7. All right, and I expect to see you solving that algebraically by setting the two functions equal to each other. So we could take 2x plus 3 equals x squared plus 3, solve that equation, and I should see that work on your paper.